So in other words, your system can be an outage for a very, very long time with respect to your packet length. You'll drop a lot of packets before you can start recovering. Over here, like I said, you can design error control code that will recover the losses. What kind of factors do you think affect whether you have fast or slow fading? Bandwidth is...
Okay, not bandwidth. Frequency modulation of the carrier. Frequency of the carrier
Yes, that's one. That's one.
how you represent your bits.
How you represent your bits, that would be related to bandwidth. I'd say bandwidth is not really an effect, but carrier frequency could be one effect. But there's a big one. So remember last time there was so all we're talking about here is the scaling, whether the amplitude scales the signal significantly. Question? Is there a comment over here?
Velocity of the vehicle.
Velocity of the vehicle, that's the big one. So remember from the example last time, we ended up with the fading term, sine pi f. It was of the form pi f bt over c. So the speed at which this your signal will oscillate depends on the velocity of your vehicle, and basically it also depends on the carrier frequency through that, but also on the speed of your vehicle. So, speed of fading. Depends on speed of the vehicle. And unfortunately, most of the fading in the world is slow. So the example we had last time, we had f 1 gigahertz, speed of light 3 times 10 to the 8th, velocity I think was 30 meters per second. I think that's right. So everything boiled down, and in the end we had sine pi 100t.
I was just thinking about like this. You've got your vehicle moving, right? So you've got the signal bouncing back, so there's the fading term that we discussed.
Yes.
And that's going to vary. Like, obviously, the slower the vehicle is, the more slowly your fading is going to be. But if you increase the frequency of your signal that you're seeing, then the wavelength is much shorter. So the fact that the vehicle is moving slowly is often by the fact that it's still moving at many thousands of wavelengths.
Yeah.
So I was just thinking, if your frequency is higher, doesn't that make slow fading seem like fast fading? Like, doesn't it help compensate?
That's exactly right. So that's the f does appear in this expression. So yeah, you're right. So frequency is absolutely correct. Bandwidth, not so much.
Yeah, I think I'm in the frequency.
Okay. Okay. So anyway, the frequency of this term is about 50 hertz. Which in duration is about 0.02 seconds. So if you have a packet of length 1000, the bit rate would have to be very, very slow. So what, in order to go through a full cycle of this in 50 hertz, or in 0.02 seconds, what would the bit rate have to be for that to be a full packet? Well, your bits would have to come in at a rate of basically 1 over 1,000 times 0.02. Actually, better do it the other way. 50 times 1,000, so 50,000 bits per second. So if that happens, then one packet will take about 0.02 seconds. So that's a relatively low bit rate as far as most or most modern digital communication systems are concerned. So relatively low bit rate or relatively high velocity will lead to fast fading. But in most practical situations, we usually think of the fading as rather slow. Speed of fading depends on the speed of the vehicle and bit rate. Okay, any questions on that?